Okay, good morning, good afternoon, good evening to everyone. Welcome to our online revision tutorials in preparation for sessional exams. So I'm going to look at the question 3, uh, which is in the assignment which we gave you, the assignment which you were given. Question number 3. I'm sure it's one of the important questions which we have to look at. And just as I emphasized to say, take these questions very much serious. So I'm going to look at question number 3. I'm sure I'll just make up the whole question if possible, A, B, C, D if possible. You can look at the whole questions A, B, C, D, so that we can have an idea on how to handle such questions. So we have the first one. The first one says, I'm sure we're able to see the question on the screen there. The first one says that prove the identity. So we're trying to prove the identity cot is cot squared. What's that? This is x minus 1. Then we have this to be equal to, this should be equals to the cosec. Cosec. So this is also squared x. So I want to prove that that is equals to that. So number one, you have to understand that what kind of a function is this? What kind of topic are we talking about? We're talking about hyperbolic functions. So basically, trigonometric functions and hyperbolic functions, these two things are basically similar. Usually, it's just, I think, a concept of the Pythagorean identity, which tends to differ. So every time, remember, as I always emphasize in class, to say, when you're looking at trigonometric identity and the Pythagorean, the hyperbolic functions. So trigonometric functions and hyperbolic functions, most of these all depends on identities. So know all those identities very well, because you'll be using them in solving equations, you'll be using them in proving other identities, and you'll be using them sometimes, in most cases, maybe graphing a complicated function being given, you're taught to graph the function. So you simplify it first before you graph it, and so forth. So once you have this, there are a lot of ways of killing your right, as long as you understand the theorems, the properties very well, the identities. This question is very much simple for you. So the first thing, or the first task you have to understand, are the identities. So what kind of identity can you grab there? And obviously, in this case, you should be able to us is to remember a number of multiple identities. For example, you can start by looking at your left hand side. What do you have on your left hand side? We have cot squared x minus 1. So recall that if you can look at this cot squared x can be written as in the form of an identity. This is more like a rational identity. So quotient identity. The quotient identity for cot is equal to what? Cos squared x over sine squared x. This is the identity for cot. If it was for tan, it is sine over cos. So basically, these are the same identities under trigonometric functions. But when you look at hyperbolic functions and trigonometric identity, the only difference is the Pythagorean identity, where sine squared plus cos squared is equals to 1, but for the hyperbolic is a minus in those Pythagorean identity. So when you recall this, automatically things already becomes very simple for you there. What can you do? You can replace where there is cot with this. It means that I'm going to have something like cot. So instead of using cot, I'm going to have cos squared. So my marker. So cos squared x over sine squared x minus the 1 should give us cosec squared x. So obviously we'll be working, let's forget about this for now. So we are going to be working on our left hand side to make sure that we obtain the right hand side. So every time you are proving identities, always start with the complicated part so that you can prove the simple part. So this topic is all about identities. Once you understand identities, everything goes smooth. So we're going to be working with the left side so that we can show the right hand side. So what can I do here? We can simplify this as a single fraction. Or if we are simplifying this as a single fraction, is going to be equals to shine squared x as the lowest common denominator. This into this is 1. 1 times that, it is equals to the cosh squared x. This into this, it is this. This minus that, it is minus shine squared x. Shine squared x. This is what I'm going to have on my left hand side. So when this is simplified as a single fraction, I'm going to have something like that. But recall from the Pythagorean identity, what does it state? It states that the cosh squared x minus shine squared x, this should be equals to what? A 1. So basically from the Pythagorean identity, we know that the cosh squared x minus the shine squared x, this should be equal to a 1 according to the Pythagorean identity. If it was a trigonometric function without hyperbolic function, the Pythagorean identity states that cos squared x plus sine squared x. But this is hyperbolic functions. Every time you see my HHI, it means we're talking about hyperbolic functions. So it means that in this case, we're looking at the Pythagorean identity says cos squared x minus sine squared x would equal to 1. So everywhere where there is this guy, we have to recall that this is basically a what? A 1. So this is equal to 1 over the shine squared x. So this 1 over shine squared h, we know that cosec here is basically a reciprocal of shine. So if we have 1 over sine squared x, automatically this is by default what? Cosec. This is by default cosec squared x as our desired right hand side. So this is a very much simple question which you shouldn't even have difficulties in solving. So every time you're solving trigonometric theories, identities, or proving identities, the only task you're required to do or memorize or be able to remember is basically identities, which will help you prove other identities. So the easiest here, or maybe what helped me to prove this identity, is recording the quotient identity for cot, and is also recording the Pythagorean identity for the hyperbolic functions. So the Pythagorean identity is cos squared x minus sine squared x equal to 1. Because we know to say when we'll be simplifying this guy as a single fraction, I'm going to end up with this, which is the Pythagorean identity, which is equal to 1, and 1 over the sine squared x. Sine squared x is a reciprocal identity. So the reciprocal of shine is going to give us a cosec. And there is, remember, these are just reciprocal identities. I'm sure I gave you even a document on all the identities on Pythagoras versus the trigonometric identities. So when you bring in a hyperbolic, you just try to put in h everywhere where there are those trigonometric ratios. But it all starts from the Pythagorean identity. So trigonometric functions, it is a plus for the Pythagorean. But hyperbolic functions, it is a minus, because all those identities are proven starting from the Pythagorean identity. So with that done, you should be able to understand that one. So we have the second part B. So the second part B there is talking about solving the equation. So we want to solve for x. So solving the equation, we're talking about 3 shine minus cosh of x to be equal to a 1. We want to solve this hyperbolic function equation, so we have to solve the value for x. So in solving the value for x, given shine and cosh in that manner, automatically the important aspect, or maybe the important thing we have to recall in this part, is basically recalling the exponential identities for shine and cosh. So recall that. So we have to recall that shine in terms of exponential functions, the shine can be given as, what is the identity for shine? Shine is given by e power x minus e power negative x over 2. That is for shine. And for cosh, cosh is given by e power x plus e power negative x over 2. That is for cosh. So once we understand this, automatically this becomes very much simple. Sometimes, this is the best card, because if it was maybe squared, someone was squared, you could have replaced maybe with the Pythagorean identity. But in this case, the easiest is using the exponential. This one will be the easiest, will be using the exponential identities for shine and cosh. So in this case, what are we simply saying? We have 3 multiplied by shine. So instead of using shine, we are going to use this C expression. So I'm going to have a 3 multiplied by e power x minus e power negative x over 2. This is the shine, minus, for cosh, it is e. Let me just write this guy. Cosh x is equals to e power x plus e power negative x over 2. So that I can have some space. So we're simply saying 3 shine is e power x minus e power negative x over 2, minus cosh is e power x plus e power negative x over 2. That is our cosh. So this expression should be equals to the right hand side, which is equal to what? A 1. So now we have to solve for the value of what? Of x. So solving for value of x, what am I going to have now? We can simplify our right hand side. So simplifying our right hand side, or the easiest is deleting the denominator first. So in deleting the denominator, what is going to happen? We can multiply the whole expression by what? By 2 to get rid of the denominator. So if I multiply the whole expression by 2, this by 2, the denominator goes, I'm going to remain 3 e power x minus e power negative x. This times that, this denominator goes, I'm going to remain with negative e power x plus e power negative x to be equals to this times this, it is equals to a 2. So that when we simplify everything, this times that, I'm going to have 3 power that. This times that, I'm going to have negative 3 e power negative x. This times that to be a negative e power x. This times that to be a negative e power negative x to be equals to a 2. From there, what can I do? I'm sure there can be some like terms happening somewhere. This one and this one are like terms, isn't it? So we have 3 e power x minus e power x. So 3 of them minus 1, I'm going to remain with 2 e power x. I have negative 3 e power negative x and minus that. Negative and negative, this is negative 3, negative 1. So by default, I'm going to end up to have a negative 4 e power negative x to be equals to a what? A 2. That's what we have. Then from there, let me just delete the top part. From there, what am I going to have? We're now going to have 2 e power x minus 4 e power negative x to be equals to a what? A 2. So what is going to happen there? We are going to have, this is 2, or we can say divide everything by 2. So if we divide everything by 2, this divided by 2, this divided by 2, this divided by 2, to just simplify things. So we're going to end up with e power x minus 2 e power negative x to be equal to a 1. We are okay? So that at this particular stage, what can happen? You can now tell yourself to say, okay, let me say this e power x can be written as e power x minus 2 over e power positive x. According to exponential function, if it is the power is negative, x can be taken in the denominator. isn't it? So now this is going to be equals to a 1 in that manner. So now the question is, how do we solve for this guy? We can still delete by the denominator by multiplying throughout. We multiply the whole this by e power x. If I multiply the whole this by e power x, what am I going to have? E power x times e power x, we have e power x squared. If you wish to, you can let e power x to be any letter of your choice, because I think it will be very much simple in that manner. If e power x is any letter of your choice. So maybe let me take it to say let e power x to be y. So it means that before you multiply, you can take it as y minus 2 over y to be equals to a 1. So that when you multiply throughout by y, you're going to have y times y, giving you a y squared minus this times y, the y goes to giving you a 2, y times this, giving you a y. This becomes a quadratic equation where everything can go this side, becomes y squared minus 2 minus y to be equal to a what? A 0. So if I have y squared, equals to y squared minus 2 minus y is equals to a 0. What am I going to have? We are going to have, can I make two values, two which can have, is it possible? Two numbers factorization method. -1, -2. Is it possible? -2. Oh, sorry, this is a constant c. So this is in the form of, I don't know if you're able to see this side, y squared minus y minus 2 to be equals to a 0. So -2 as the product, the sum is -1. So we're talking about a constitution, we're talking about y squared minus minus 2y positive y minus 2 to be equals to a 0 in that manner. So that the two numbers are -2 and +1. -2 times +1 is -2. -2 plus 1 is -1. So that when we factor out, we have y, open bracket, y minus a 2 plus y minus a 2 to be equals to 0, implying that I'm going to have y minus a 2 equals to 0 and y plus 1 equals to a 0. So this is going to be equals to y equals to a 2, and this is going to be equals to y equals to -1. But this is not our desired solution. We have to solve for the value of x in our equation. So what do we have to recall here? We have to represent this y to be something. What was y? Y was now e power x. So we said let to a power x be y. So since e power x is now y, so we'll replace back e power x. So this means that e power x here should be equals to a 2, or e power x here should be equals to what? -1. Now we have two solutions there, and we have to understand that according to exponential properties, e power x, this as an exponential property or as an exponential function, can never produce a negative y value. The range for this exponential function, when sketched, it is always starting from any value which is greater than what? Greater than 0. It can be a negative y value. So this part here, which we are going to have here, is an invalid solution. So this part which you are going to have here is an invalid solution. The only part which will be valid, it is that part which is giving us a positive y value. So we are now going to solve for this guy. Allow me to delete this part again. My body is smooth. So implying that I'm going to have e power x to be equals to a 2. So e power x equals to a 2. We're solving for x. Making the x come down, it means we have to apply a log on both sides. And since we have an e, we can apply the easiest, which is the natural log. That to be equals to the natural log of 2. Power rule, the x drops down, x times natural log of e to be equals to the natural log of 2. Natural log of e is equals to what? A 1. 1 times x is equals to x, and x will now be equals to the natural log of what? The natural log of 2 as our solution. So when we solve the equation, Therefore, if we solve the equation which was saying 3 sine x minus cosh x equals to a 1, if we solve this equation, we are going to have the value of x, which is valued to be the natural log of 2. And since Ma-110 we don't have calculators, we will leave our answers like we are able our answer in that form to say the value of x is basically equal to the natural log of 2 as a solution. So we have another one there which says that prove that tan squared x is equals to cosh 2x minus 1 over cosh 2x plus 1. We have to show that the left side, which is tan, is equals to cosh 2x minus 1 cosh 2x plus 1 as the denominator. So how do we show that? The same thing I said when solving the proving for A is the same thing I'm saying now, that when it comes to proving, you have to be able to remember or recall certain identities which will help you prove these other theorems. So identities will always be there to help you prove other complicated identities. So those identities which were given to you when we are learning physics in class, be able to know them very well, and they'll be able to assist you in proving these other complicated identities. So now, when you want to prove this, what should be the first task? Yeah. So remembering identity. So we have to recognize that Tanch by default Tanch is a quotient identity. It's made up from a quotient identity. I'm sure we all know that. So obviously, we know sometimes maybe when you simplify it, because when proving identities, we always start from with the complicated part. This is a simple, a singular part. So we always start with the complicated part. We start with this complicated part which we have. Okay? So we are going to use the right hand side to show the left hand side. This is what we're going to do, because the right hand side, it is the complicated part. So what identity can I recall if I look at my right hand side? I'm able to remember that the double angle here, which is cosh 2x, is basically giving me a certain identity which says that cosh squared x, I'm sure you can remember this, cos 2x is equals to cos squared x plus sine squared x. This is the identity which you are trying to recall. So recall this identity. So it means from my right hand side, so we are trying to recall this. So from my right hand side, everywhere there is cos 2x, I'll be able to replace with that guy. So implying that instead of using cos 2x, I'm now going to use cos. So in short, I was simply saying everywhere there is cos 2x minus 1 over cos 2x plus 1 will now be written as cos squared x plus sine squared x. Everywhere there's this, but remember this is a minus 1 here, and in the denominator again we have cos squared x plus sine squared x, and we have a plus 1, which is the following contantial. Then the next part, what is going to help me again? Basically, it's just identity. I'm sure I know there are a lot of identities, and some will use other identities. It depends on whatever you see to be the simplest to work with. So it's just using identities. What is simple for you? Use those identities. If they are working out, sometimes maybe what I've used is not okay with you. You can also use another identity to show something else, as long as it is justifiable. So according to this, I've justified my identity there. So that is my identity is going to be given. I'll use that, replacing it. No, Ma-110 is all about mathematical method. It's all about you understanding the methods. Everything what you are doing should be able to clearly state with justification. So I'm able to tell that cos 2x, recall that cos 2x is equal to that. It means that even if nothing changes from cos 2x, I replace with this. I've already stated that cos 2x is equal to that. So someone who is even marking my paper won't be non-kind, even if the marking key is something else, won't be confused on how things have come about. So this will be replaced there, and the same guy will be replaced there. Minus a 1 plus a 1. That's what I have. And then from there, what is happening? We'll simplify both the left and the top part and the right part. So what is happening again? We'll have to recall the identity, another identity here. So what identity am I going to recall? Recall the Pythagorean identity, that cos squared x minus sine squared x is equals to 1. This is the Pythagorean identity. So it is from this guy. Now, because of the fact that I have cos and sine, it is very much difficult for me to bring in something to me to just, I need to work at least with one trigonometric relation instead of cosine. So obviously I can make one guy the subject here. If you want, you can make sine the subject. If you want, you can make cos the subject. I'm sure it will still work around. So I'm going to make cos the subject here. It means that cos, for me to have cos squared x will be equals to, when this goes to the other side, becomes 1 plus sine squared x. This is what I'm going to have. So 1 plus sine squared x. So where there is cos squared x, I'm going to put this guy. So implying that this is now going to be equals to, after the cos here, it is now 1 plus sine squared x. 1 plus sine squared x, but there is this guy plus sine squared x. Outside here, we have a minus a 1 over, there is this guy here, we replace again 1 plus sine squared x. This still intact in the expression, sine squared x. Outside here, we have a plus 1. Since breaking the brackets with a positive, this can still come out broken down just like that. You no longer even have brackets. Then simplify. So like terms here, what is going to happen if we group like terms? We're going to have a 1 minus a 1, which is a 0. And we're going to have 1 plus a 1, which is a 2. Am I correct? Yeah. So let's continue with it. Let me just delete the top part here. So what am I going to have? I'm going to have this plus this. So this plus this is going to give me, this is now going to give me, this plus this is going to give me 2, because these are the same. So these are like terms, one of this plus one of that. I'm going to have 2 sine squared x. 1 minus a 1 is a 0. So we have 0 that side, over, because this will cancel out. In the denominator here, it is 1 plus 1, which is giving me a 2. So I'm going to have 2 plus this, I'm going to have what? This is sine squared h, this plus that to be 2 of them, 2 sine squared x, in that manner. So if that is the case, obviously in the denominator here, you can factor out the 2, which is common, and this is now going to be equal to 2 sine squared x over 2 sine squared x over, these 2 can be factored out, multiplied by 1 plus, what am I remaining with here? It will be a sine squared x. So this is multiplication here, this is multiplication here, means 2 divided by 2, they can go out. We'll now remain with sine squared x over 1 plus sine squared x. Now, how do we simplify that one so that by the end of the night we end up with our left hand side, which is our desired solution? You still recall, look at this. 1 plus sine squared x is the same thing you had to let to say it is equal to what? The cos. So everywhere there is 1 plus sine squared x, it is still equal to what? Cos. You already had to let it there in the beginning. So this means that I'm going to have this to be sine squared x to to be equals to set of 1 plus sine squared x, I will now put in cos squared x as my desired solution. And we know that tan is basically a what? A quotient, is made up from a quotient identity. Tan squared x should be equals to sine squared x over cos squared x. So it means that if we have sine over cos, by the end of the night, I need to have tan squared x as my desired solution, and this is our left hand side, and hence this has been proven. So when it comes to proving identities, what are you supposed to remember? Just be able to remember your identities. Identities, very much important. Thank you very much. See you in the next video where I can talk about sketching polar equations. I will sketch polar equation in one video and be able to send through as well. Thank you very much, and blessed morning, day, afternoon, and evening.